We're going to start our new unit, Unit 6, and it is called Systems of Linear Equations. So we're going to use what we learned in Unit 5 with graphing lines, point slope, slope-intercept form, all of that stuff to kind of build and develop a new skill. Okay, so instead of just dealing with one equation and one graph, we're now going to work with multiple lines, multiple graphs, and we call that a system. So a system of linear equations is two or more equations that work together and they share the same variables. That's important. So both equations you're working with will have the same variables. Typically in this unit it will be x and y. Okay. So what is the point of a system? Why are we looking at this? Well, a system can be really great. If we have two unknowns and two pieces of information, we can use those two pieces of information to help us find a solution, to find x and y instead of just finding x like in a normal equation. So a solution to a system really is going to be both the x and the y that's in that equation. So we can also say that that's any ordered pair. So like an x comma y, and it has to satisfy all the equations in the system. Now, typically in Algebra 1, we only deal with systems that have two equations. We don't deal with ones that have three. But a system theoretically can have lots of different variables. Okay, so let's take a look at the three types of things we're going to be looking at in this unit. So these are the three types of solutions to systems we're going to see in this unit. So the first type is something that looks like graph A, where I've got two lines that are basically just intersecting. This type of solution is a one solution. And the one solution is right there, where the two lines intersect. So the line intersects at a point. Like I said, that's going to be, oops, I'm kind of off the map here. Let me make that a little bit bigger. There we go, that's better. Okay, so they intersect at a point, and that point is your solution, x comma y. So that's your general solution, is just two lines intersect. Okay, one solution. Another type of solution we have, now I know the second one looks like there's just one line on here, but really if you're graphing or solving two lines that end up having the same graph, we call that infinite solutions. And we've worked with this before when we had all real solutions back when we were solving equations, so that a very similar thing happens here. Okay, if it's the same line, if both lines are the same, they will look like they lie on top of each other. Okay, and any x comma y will work. Well, any x comma y that falls on that line. Okay. And then the last type of solution you're going to see in this unit is where the lines are parallel and they'll never intersect. And this is, hopefully maybe you guessed it, this would be no solution. Sometimes you can have a system where there's no x and no y work, and they'll never intersect, they'll never cross, so there's no solutions. In this case, the lines never intersect or cross. They are parallel. They'll have the same slope, and we learned that last unit about parallel lines having the same slope, and no xy will work with this. Nothing will satisfy. So these are the two types of solutions we're going to be looking at for a system. So let's take a look. Now that we talked about solutions, let's take a look at what the actual problem might look like. Okay. So this right here, let me go up here. Here we go. Okay, so example A, this is what a system looks like. Okay, it's two equations kind of listed on top of each other like this. So A has one equation listed here and a second equation listed there. So that's a system, two equations in working together. Sometimes you'll see them written where they have a squiggle bracket around them to show that they're a pair. So in this example, we want to determine if the point 2, 5 is a solution to the systems. So when I have a coordinate pair, I'm instantly going to label that 2x and that 5y, okay, because that's how a coordinate pair works. And if I want to see if 2, 5 is a solution, what I'm going to do is I'm going to plug 2, 5 into both of these equations. So I'm going to rewrite my first one over here. And instead of, oops, let me back up a little bit. So I've got y equals 4x minus 3. And I've got 2x plus y equals 9. So those are my two equations. Now I'm going to plug the numbers 2 and 5 in for x and y. So for the first equation, instead of y, I'm going to plug in 5. And instead of 4, I'm going to plug in 2. And then I'm going to go ahead and simplify this. I'm going to leave 5 on the left. And on the right, 4 times 2 is 8. And what is 8 minus 3? 5. So when I plug in 2, 5, it works because it's the same on both sides. So let's try it in the other equation. So I've got 2 parentheses 2 because x is 2 plus 5 because y is 5. I'm going to simplify. 2 times 2 is 4. And 4 plus 5 is 9. So since it works in both, then I can say that yes, 2, 5 is a solution. It has to work in both. So let's try the second one. Do the same thing. We're going to rewrite each equation off to the side here. And now we're going to plug 2, 5 in for this one. So for the first one, y minus x, that's going to be 5 minus 2. That one does work. I get 3 equals 3. The other one, I'm going to get 5 equals 1/2 2 plus 6. 1/2 times 2 is 1. But is 1 plus 6 5? Nope. So this does not work. So no, 2, 5 is not a solution. The coordinate pair has to work in both for it to be a solution. Okay, so this is the algebra reasoning for why something's a solution or not a solution to a system. But now, what happens if I give you these equations and I say, hey, look, here's a system, like an example B. How do I know which coordinate pair is going to work? So if I give you two equations, how can you tell me which point will work in both of them? You could guess and check a lot if you wanted to. It would take you a really long time. So instead, the first method we're going to learn to do that is called the graphing method. And it basically is what it sounds like. You're going to graph both equations on the grid. So I'm going to go ahead and rewrite this second equation into y equals mx plus b form, because that's a much easier way to graph. So for this first equation, my starting point is 5. So I'm going to draw my first dot at 5 over here. My slope is 2, and you can even write the over 1 if you want. So your rise over run is 2 over 1. So we're going to go down 2 over 1. And for these, I like to make enough points to fill the grid because you don't know where the lines are going to intersect. And so you want your line to be as straight and precise as possible. So make as many points as you can. Okay. The next equation, my starting point is at 2. So I'm going to make a dot at 2. And then my rise over run is invisible, -1 over 1. So I'm going to go up 1 over 1. And I can kind of already see that is the point where it's going to touch. So I'm going to make some more points here to finish it up. I'm going to connect my dots. Kind of goes off the page there. Okay, and now I'm going to say, okay, well, they intersect at this point right here. Okay, so that's my then solution, -1, 3. Okay. And if I wanted to show that that's a solution algebraically, I would do what I did in example A. I'm going to rewrite each equation. Y equals 2x plus 5 and y equals 2 minus x. I'm going to plug those numbers in. So 3 equals 2 -1 plus 5. And that is going to give me 3. And 3 equals 2 minus -1. Because remember, there's a negative here, and there's a negative in my 1, so I'm going to have 2 negatives, and that's going to give me also a 3. So it does work. It works algebraically, and it works graphically, so I'm pretty confident that this -1, 3 is my solution to this system. Okay. So let's try another one here. Let's try example C. And if you want to pause and try this on your own, you can. Sometimes that's a good strategy to see if you understand, but we should be pretty good at graphing y equals mx plus b. All you're really doing in this learning target is doing it twice. So for my top equation, I start at 4, so I make my point at 4, and my slope is -1 over 2, so I'm going to go down 1 over 2 this way, make some points, connect my dots. Okay, so that's the first line. The second line starts at -1. So I'm going to make my point at -1. And my slope is 3 over 4. So I'm going to go up 3, 1, 2, 3, 1, 2, 3, 4. 2, 3, 1, 2, 3, 4. I'm going to connect my dots. And I can see that they intersect right here at this point. And that coordinate pair is 1, 2, 3, 4, up 2. So my solution to this system is 4, 2. Not so bad, right? The last example that I want you to take a look at is, so we've talked about now the equations that have one solution. But remember in the beginning of the lesson I talked about sometimes systems have no solutions and sometimes they have infinite solutions. So I want to take a look real quick at what that might look like a special case. Okay, so here I've got two equations like before, and I'm going to go ahead and solve them graphically. So this first one starts at -7, that's way down here. And the slope is -3 over 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's my line for that one. Okay, so that's my first line. My second line starts at +4. And it also has the same slope. Now that should be kind of like a red flag. Oh, they have the same slope. What did I remember about lines that have the same slope? They're parallel. So it should kind of be a clue that these guys might have an interesting solution. And notice when you graph them, are they ever going to intersect? No. These lines are going to be parallel. So your answer to this is no solution. They won't ever cross. There's no x and y that satisfy this system of equations at all. Okay. So that's the introduction to systems solving using the graphing method. We will learn 2 other methods that get a little bit more challenging. So we're kind of starting you off simple here. So you're really just kind of reviewing your graphing skills and being able to graph more than one line on a grid and make a conclusion about what that might mean. Okay, so good luck on your practice, and I'm here if you need help.